Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. Hi Arush, good evening. Welcome to the session. So I hope you must have revised the practice questions we have completed in the last class. It is about the chapter acid, bases and salts. So in this particular session or in this class, we are going to discuss the first chapter questions, chemical reactions and equations. Ready? Okay, fine. We are directly moving to our first question. You read the question properly. This is the first question. We must have studied in the chapter chemical reactions and equations about the different types of reactions, right? So based on that idea, you need to give the answer for this question. Choose the correct option. 4 different reactions are given here. We need to identify the specific names for all of the reactions. I hope you understand the question. Arush, are you sure option D is the correct answer? Yes, let's see the answer here. Option D is the correct answer, which means, what do you mean by the first reaction here? What are you observing here? A plus BC gives AC plus B, right? What you're observing here, the element A is replacing the B, right? So this is a displacement reaction. We have already studied about the types of reaction in the case of chemical reactions in the equations chapter. So one of the reaction is a displacement reaction. Right, clear? So this will be the displacement reaction. What about the second reaction? X gives Y plus Z. As we already know by the definition, any of the single reactant break down into 2 or more products, we can be called it as an decomposition reaction, right? Decomposition reaction. Then what about the third case? PQ plus RS gives PS plus RQ, right? This is also a displacement reaction in which 2 of the elements are displacing, right? So this is a double displacement reaction. Double displacement reaction. Then what about the last case? A2O3 plus 2B gives B2O3 plus 2A. If you are focusing about the reaction given here, what you are observing, the B can displace the A element from their oxide, right? So this is also again a type of displacement reaction. A type of displacement reaction. So altogether when we are comparing or when we are observing here, we can say that option D will be our correct answer. Displacement is the first reaction, decomposition is the second reaction, and double displacement is the third reaction, and again displacement reaction is the fourth one. Is that clear? Is that clear? Just let me know in the comments. Yes. Can we move to next question? Here is our next question. Read the question properly. The question is based on the oxidation number of nitrogen in the case of NH2 compound. This is the second part we have studied in the case of this chapter, that is about the oxidation reduction, how to find out the oxidation number for a particular compound or the element. So based on that idea, you need to give the answer for this question. Read the question properly. It is asking about the oxidation number of one nitrogen atom present in the case of compound NH2NH2. What will be the answer? Just calculate the oxidation number and give me the answer fast. Options are given here as +2, -2, -1 and -4. No answers? Arush, is this your answer is option 2 or answer is +2? Okay, let's see what will be the answer. Option B will be the correct answer, which means -2 is the oxidation number of nitrogen in the case of NH2, NH2. Okay, what do you call it as this particular compound? This is a particular compound known as hydrazine. So instead of NH2, NH2, if you are asking about the oxidation number of nitrogen in the case of hydrazine, you will calculate like this. How many nitrogen atoms are present in the case of hydrazine? How many nitrogen atoms are present in the case of nitrogen? Two, right? Two nitrogen atoms are present here. The oxidation number of nitrogen we don't know, we need to calculate. So I am taking as an x value here. This is a general method to calculate the oxidation number. So total 4 hydrogen atoms are present, right? Total 4 hydrogen atoms are present. For each hydrogen atom, they have an oxidation number of +1. So total together it will be 2x plus 4. As we already know, the rule for oxidation number, rule for calculation of oxidation number means the sum of oxidation numbers of each of the elements will be equal to the sum of 0, right? Sum of 0. So if you are calculating here, you will get 2x equal to -4, the normal mathematical calculation. X is equal to -4 by 2, that is equal to -2. Is that clear? Is that clear? Arush? Okay, I will repeat it again. If you are asking about the oxidation number of any of the compound or element, right? For example, if you need to take the oxidation number of For example, you are taking the oxidation number of oxygen in the case of water. As we already know, it will be -2. In a simple method, we can calculate this like that. What will be the oxidation number of hydrogen? What will be the oxidation number of hydrogen? 1, right? So here in the case of H2O molecule, 2 is the oxidation numbers of 2 hydrogen atom plus the oxidation number of oxygen we need to be calculated, that will be taken as x. That will be equal to the sum of 0. For a neutral molecule, the total sum of oxidation number of each of the element present on it will be equal to the value of 0. If for example, if you are taking NO3 minus, if you are taking NO3 minus, right? We need to find out the oxidation number of nitrogen. If you want to find out the oxidation number of any of the element, we can just take it as an x here. So x minus, for 1 oxygen atom it will be -2, right? For 3 oxygen atom it will be 3 into -2, that is equal to -6. So x plus -6 is equal to, what will be the sum here? In the case of an ion, it will be the charge given over it. Are you getting my point? Arush? I hope you must have studied about the term valency, right? In the case of hydrogen, it will be equal to valency as well as oxidation number. So what is the case of hydrogen? There will be 1 electron, right? 1 electron. So the number of electrons that can be removed is known as the valency. So in the case of hydrogen, there is only 1 electron. That will be the oxidation number as well as valency for the particular case of hydrogen. In the case of in the case of oxygen, it will be -2 in the case of almost all the cases. So what will be the charge given here? It will be -1, right? It will be -1. So if you are taking here, So plus Y will be the oxidation number of nitrogen. Then minus 2 will be the oxidation number of oxygen in the case of water. Is that clear? Yes, Arush, just think about that. You can take many of the examples. You need to check whether it is getting the valency or not. I think there is more points will be given in your given in your NCERT textbook based on the calculation of oxidation number. Okay, in order to find out the oxidation number, we will be having more questions in the next slide also. I will be discussing later. Fine. So now let me move to the next question. Okay, here is the next question based on the balancing of equation. In the following equation, Na2CO3 plus XHCl gives 2NaCl plus carbon dioxide plus water. What is the value of X given here? We need to find out the coefficient of HCl in the balanced chemical reaction for this equation. Okay, what will be the answer? Options are given here as 1, 2, 3 and 4. So option B will be the correct answer, which means 2. So first we need to balance the equation, right? Na2CO3. Okay, what is the basics of balancing equation? Which law is preferred by the balancing of equation? Law of conservation of mass, right? I hope you must have idea about the law of conservation of mass, which means that the total mass of all the reactants should be equal to the total mass of the products according to the law of conservation of mass, right? So what we have to do here, we need to maintain the total mass of reactant is equal to the total mass of the products. So what you are observing here, in the case of left hand side, in my left hand side, it is 2 sodium is present, right? In the case of reactant part, 2 sodium is present. In the case of product side, it is again 2 sodium. So sodium is balanced. And what about the case of carbon? Here only 1 carbon. Here is also 1 carbon. So this is also balanced. And what about the case of oxygen? Here it is 3 oxygen. Here is its total together 2 oxygen from the carbon dioxide plus 1 oxygen in the water. All together it will be 3 oxygen. So number of oxygen is also balanced here. What is remaining here? If you are checking the number of hydrogen, right? If you are checking the number of hydrogen, here it is only 1, but in the case of product side it is 2. So I am just multiplying this HCl with 2 to get the number equal. So what you are observing now? Hydrogen is also balanced as 2 and chlorine is already balanced as 2. So this will be the balanced equation for the reaction. So our question is we need to find out the coefficient of HCl. That will be equal to 2. So option B will be the correct answer. Is that clear? Okay, Arush, take any one of the example given here, then I will explain the oxidation number for that. Which one you want? Carbon dioxide, water, NaCl, HCl or Na2CO3? Na2CO3, right? Okay. Okay. Okay, in the case of Na2CO3, I hope you must have idea about the oxidation number of carbon, right? Oxidation number of carbon and oxygen. Then what about sodium? Okay. For example, if I am taking the oxidation, if I need to calculate the oxidation number of carbon in the case of Na2CO3, what I have to do the first step is that I need to add the oxidation numbers of each of the atom present here, right? So how many sodium atoms are present in the case of Na2CO3? Na2CO3, how many sodium atoms are present? 2, right? So what will be the oxidation number of sodium? If you are connecting with the valency. One, right? Yes, sodium is having the oxidation number of +1, so it will be 2 into 1 for the 2 sodium atoms. Then I don't know the oxidation number of carbon, so I am taking it as X. Plus, what will be the oxidation number of 3 oxygen atoms? Three oxygen atom. For one oxygen atom, it will be -2. For 3, it will be 3 into -2, that is equal to -6, right? In total, for a compound, it will be equal to 0. The total sum of the oxidation number will be equal to 0 for a neutral molecule because there is no any charges given here, right? So I am taking it as a 0 here. Now we need to just do the calculation here. X minus 4 is equal to 0 or X is equal to +4, which means that in the case of Na2CO3, carbon is having the valency or oxidation number of +4. Is that clear? Okay, just for a reference, I have taken carbon as the first case. Similarly, you can calculate the oxidation number of sodium also by using the other method. If you are knowing about if you are aware about the oxidation numbers of carbon and oxygen, you can find out the oxidation number of sodium also. Clear? If you are doing the same method, you will be getting the oxidation number of sodium in the case of Na2CO3 will be equal to +1. Is that clear? Okay. Then for example, in the case of carbon dioxide, what will be the oxidation number of carbon? Okay, this is again the example of polyatomic, right? Polyatomic means which contain more than 3 or 4 atoms. So here it is again 3 plus 2 plus 5. 6 atoms are present. So this is an example of polyatomic molecule. So in the case of carbon dioxide, if we want to calculate the oxidation number of carbon, again X minus 4 is equal to 0 or X is equal to +4. So again carbon is having the valency of +4 in the case of carbon dioxide. Clear? Okay. Here is the case, right? I need to find out the oxidation number of carbon. I am taking the oxidation number of carbon as X, which is an unknown value. For one oxygen atom, it is equal to -2. For two oxygen atom, it will be equal to -4, right? In order to add X plus -4, I will written as X minus 4 only. Is that clear now? Arush? This is the same only, that is X plus -4 is equal to 0. Clear? Okay, now let me move to the next question. Here is our next question. A particular reaction is given here. Magnesium is reacting with copper oxide to form magnesium oxide plus copper. Which of the following is wrong relating to the above reaction? Okay, I will explain the oxidation number of ions after completing the question. Please give me the answer for this question. This is a particular reaction. Magnesium is reacting with copper oxide to form magnesium oxide and copper. Read the options properly. First option is given as copper oxides get reduced. Second one, magnesium gets oxidized. Third one, copper oxide acts as a reducing agent. And last one, it is a redox reaction. Okay, Arushi is saying option C will be the correct answer. All are correct. Option C is the correct answer. We need to find out the wrong statement, right? We need to find out the wrong statement. So this will be the wrong statement. Let us check once again. So how we can find out in a particular reaction what will be the oxidizing agent or reducing agent in terms of oxidation number. So first step we have to do like that. We need to find out the oxidation number of each of the atoms present in the reaction. So if I am asking about the oxidation number of pure magnesium element, what will be the oxidation number of magnesium? Oxidation number of magnesium. Okay, this is a special case in which if you are taking a pure element, for example, for an atom in the case of magnesium, calcium, sodium, this is a monoatomic molecule, right? This is the monoatomic. For example, if you are taking Cl2, H2N2, this is a diatomic, right? This is a diatomic. If you are taking S8, it is polyatomic, P4. If any of the element are in their atomic state or elemental form, they must have the oxidation number of 0. Is that clear? In the case of monoatomic, polyatomic or triatomic or tetraatomic elements, if you are there in the pure form, they will be having the oxidation number of 0. Is that clear? So what will be the oxidation number of magnesium here? Because it is a monoatomic molecule, right? So it will be 0. What about copper? Again, it is also monoatomic, right? So it will be in the pure elemental form. It is again having the oxidation number of 0. Then what about in the case of copper oxide? What will be the oxidation number of copper? Arush, I didn't get your question about the subscript and superscript. If any of the elements which are there in their pure form, it will be having the 0 oxidation number, whether it is monoatomic, diatomic, tetraatomic or polyatomic. Clear? These are the examples. So here, if you are calculating the oxidation number of copper from the copper oxide, generally oxygen is having the oxidation number of -2. So this will be -2. So obviously it will be +2 in order to make the total value of 0. Otherwise it will become +2, right? So +2, -2 in the case of here. Again in the case of magnesium oxide, it is -2 and +2. Is there any doubt? In the case of magnesium oxide, it cannot exist as a pure elemental form because it is a compound combining with the oxygen forming an oxide compound. So it is having an oxidation number of +2 by taking the electrons, right? +2. So what you are observing here, if you are comparing the oxidation numbers of magnesium only, what you are observing, the oxidation number is increases from 0 to +2, which means that oxidation number increases or oxidation happens. Is that clear? Is that clear? First, you need to calculate the oxidation number of each of the elements given in the reaction. Then check which one is having the oxidation number increases. That will be the oxidation. Which one is having the oxidation number decreases. That will be having the reduction. So here in the case of copper, it is reducing, right? In the case of copper, its oxidation number decreases from +2 to 0. So it will be reduction here. So we can say that in the particular reaction, right, reduction as well as oxidation happens simultaneously. So this is a redox reaction. This is a redox reaction, right? Okay, in order to solve this type of oxidation number method, you must have idea about the oxidation number of general elements. It is very easy because it is given as the oxygen. As we already know, oxygen is having the oxidation number of -2 in the general cases. Clear? So here, oxidation and reduction happens, which means it is a redox reaction. So this is the correct statement. Then what is obtaining here? Mg gets oxidized, right? Mg is changing oxidation number from +0 to +2, which means it is oxidized. So this is also correct statement. Then what about the CuO? Copper oxide is reduces, right? Copper is reduces from +2 to 0, which means that this is also correct, right? This is also correct. Copper oxide gets reduced. Then what do you mean by the reducing agent? What do you mean by reducing agent? Arish, you will get a better idea about the elements in the case of periodic table when we are discussing about the periodic table. Okay, in the next class I will be back with the same chapter, classification of elements and periodicity. Yes, oxidizing agent means that one helps in the oxidation of other element. Yes, that is correct. Or itself undergo reduction, right? It is itself undergo reduction. For example, if you are taking copper oxide, what is happening to the copper oxide? It undergo reduction, right? It undergoing reduction, which means that it will be an oxidizing agent. Are you getting my point? This will be the definition of oxidizing agent. It helps in the oxidation of other element by itself undergoing reduction. So in order to check the reducing agent or in order to check the reducing agent, in order to check the oxidizing agent in any of the reaction, first step you need to check that whether it is undergoing reduction or not. So if you are checking here, we can say that copper oxide is undergoing reduction, which means that it will be an oxidizing agent. Is that clear? So here in the case of option C, it is given as CuO, copper oxide, act as a reducing agent, which is a wrong statement according to this reaction. Is that clear? Okay, I hope you understand. Now let me move to the next question. So this is another question based on the oxidation number. Okay, first case in the case of general elements, hydrogen, right? Hydrogen is having the oxidation number of +1 in all the cases. Again, some exceptions are there, but in general, hydrogen is having the oxidation number of +1. Then, if you are talking about the first group elements, right? First group elements. What are the first group elements? So this is a general term you need to keep in mind. In the case of hydrogen, it will be having the oxidation number of +1 in general, all the cases. Then for all the group 1 elements, it is having the oxidation number of +1. If you are asking about Li, it will be Li plus. For Na, it will be Na plus, K plus, Rb plus, Cs plus, and so on. Then whatever the group 2 elements, generally it will be having the oxidation number of +2. You will be getting more idea about when we are teaching about the classification of elements, the complete periodic table, right? Then in the case of oxygen, generally it is having the oxidation number of -2. Then for carbon, it will be +4. Clear? From group 3 to 4, there will be some variations. They can, because we have already know, right, they are the D block elements. You will get idea about when we are teaching about the periodic classification or the periodic table. Group 3 to 12 means they are the D block elements. They have the capacity to show more than one oxidation state. So we cannot predict from the group 3, they have the +3 oxidation state. Okay, what about the answer here? Na2O2. Okay, just go through the periodic table. We can say that hydrogen has no any particular position, that it will be in the middle of the periodic table because it acts as the behavior of group 1 elements as well as the group 17 elements also. So there will not be any particular position for the hydrogen in the periodic table. Hi Gautam, good evening. Yes, let's take the answer here. For 2 sodium, we need to find out the oxidation number of oxygen, right? For 2 sodium, it will be 2, right? Because 1 sodium, it will be 1. Oxidation number is +1. For 2 sodium, it will be 2 plus 2 plus 2 plus 2x. In total, it will be equal to 0, right? It will be equal to 0. So what you are observing here? Okay, is that clear? Na2O2 means in the case of 1 sodium, I have already mentioned that for all the group 1 elements, it will be having the oxidation number of +1. So sodium is a group 1 element having oxidation number of +1. Here we have 2 sodium atoms. So it will be 2 into 1 plus x number of, x will be the oxidation number of, okay. In the case of sodium, 2 into 1 will be the total oxidation number of sodium. Then we need to find out the oxidation number of oxygen here, right? 2 oxygen are present, so it will be 2x. 2 plus 2x is equal to 0 or 2 is equal to -2x. If you are calculating, you will get the oxidation number of oxygen as x is equal to -1. And we have already told like that in the case of oxygen, it will be having the -2 oxidation state, right? Oxidation number of -2 in general case. But this is a special case in which this particular compound is known as peroxide. Clear? So in the case of peroxide only, it will show the oxidation number of -1. Is that clear? Arush, you need to calculate once again. Gautam, is that clear now? You need to calculate once again. You made some mistake in somewhere here. Just check the oxidation number of sodium here as 2. It will be, sum will be 2 plus 2x equal to 0. or 2x is equal to minus 2 or x is equal to minus 1. You will get the correct answer as minus 1 only. Okay, I hope you understand. Now let me move to the next question. Okay, which of the following statements are correct for the given chemical reaction? Okay, 1 second, I will go to the last question. What is our question, Arush? It is asking about the oxidation number of oxygen in the case of Na2O2. So the unknown value will be x here in the case of oxygen. So 2 into 1 will be the oxidation number of 2 sodium plus 2 into x. 2 oxygen is present. We don't know the value of oxidation number, so I will take it as x here. 2 plus 2x equal to 0, or 2x is equal to minus 2, or x is equal to minus 1. I hope you understand now. There is no need to confuse. There is only small mathematical calculations. Okay. Okay, what about the next question? Which of the following statements are correct according to the given chemical reaction? Lead oxide is reacting with carbon to form lead plus carbon dioxide. 4 different options are given here. First one, lead is reduced. Second one, carbon dioxide is oxidized. Third one, carbon is oxidized. Last one, lead oxide is reduced. Gautam, my name is Surya. Okay, what will be the answer for this question? What is the first step you have to do? You need to find out the oxidation number of each of the atoms, right? Each of the elements or atoms present in the reaction. So in the case of oxide, it will be having the oxidation number of minus 2 for oxygen. So obviously it will be having plus 2 in the case of lead. Then only it will become equal to the sum of 0. Then what about carbon? Carbon is in the pure elemental state. So it will be having the oxidation number of 0. In the lead also pure elemental state, it will be 0. For carbon dioxide, for carbon it is plus 4 and oxygen it will be minus 2. So option B will be our correct answer, in which 3 and 4 are the correct answer. 3 and 4 are the correct answer. Let's check first. What you are observing here in the case of lead? Oxidation number decreases, right? Plus 2 to 0, oxidation number decreases, which means that this is a reduction. Right? Then what about carbon? Carbon is increases the oxidation number from 0 to plus 4. So this will be the oxidation. Clear? So carbon is getting oxidized. So this will be the one of the option. And not about lead, it is a lead oxide. Lead oxide is reduced to lead. So 3 and 4, which means option B will be our correct answer. Is that clear? Okay, I hope you understand. Now let me move to the next question. Again, a reaction is given here. Zn plus H2SO4 dilute gives ZnSO4 plus H2. You need to identify which type of reaction it is based on the idea you have studied about the type of reactions. Options are given here: decomposition reaction, single displacement reaction, combination reaction, and synthesis reaction. Okay, I couldn't see any answers in the comment box, so I will explain first. Option B will be our correct answer because it's a single displacement reaction, which is already we have studied in the second chapter also, acid, base and salt, right? Here the metal is reacting with this acid to form corresponding salt plus hydrogen, right? So what you're observing here, zinc being more reactive can displace the hydrogen from the sulfuric acid. So this is a single displacement reaction. Option B will be our correct answer. Now let me move to the next question. Okay, this is a repeated type of question which we have already discussed in the third chapter, metals and non-metals. When some metals are exposed to moisture, acids, etc., they tarnish due to the formation of respective metal oxides on their surface. This process is called. Okay, what will be the answer for this question? Yes, corrosion, right? So option B will be our correct answer, which is we have already discussed in two chapters, first chapter as well as third chapter. So I think there is no need of more explanation for this question. Corrosion. Now let me move to the next question. In the context of redox reactions, the removal of hydrogen from a substance is known as. Removal of hydrogen. Options are given here as oxidation, dehydration, reduction and dehydrogenation. So option A will be the correct answer, that will be oxidation, right? So as we already know, if you are adding oxidation, addition of oxygen or removal of hydrogen is known as the oxidation. Similarly, we can define the reduction as removal of oxygen and addition of hydrogen. So this is the classical concept of oxidation. Yes, tarnishing is also a type of corrosion, right? If you are specifically asking about the copper, it will be tarnishing. Otherwise, we can give it as a term of corrosion also. Okay, now let me move to the next question. In the reaction 2K plus Cl2 gives 2KCl, the oxidation state of chlorine changes from. Again, based on the question about the oxidation number, try to find out the oxidation number of chlorine in the case of this particular reaction. And give me the answer first. Options are given here as -1 to 0, 0 to -1, 0 to +1 and +1 to 0. Yes, option B will be the correct answer, that is 0 to -1. Yes, Arush, you are correct. So I think there is no need of explanation, right? Chlorine is a pure elemental form because it is a diatomic, so it will be having 0. In the case of KCl, K is the group 1 element, right? Potassium is the group 1 element having the oxidation number of -1. So it will be having the oxidation number of -1 in the case of chlorine. So it will be changing from 0 to -1 because it is a reduction. Clear? Here is our next question. What is the reducing agent in the following reaction? the reaction of iron with chlorine to form iron chloride, FeCl3. Again, you need to check the oxidation numbers of each of the element, each of the reactant and product given in the reaction. So what will be the oxidation number of iron here? Iron is in the pure elemental form, so it is having the oxidation number of 0 here, and chlorine is again elemental form, again it is 0. In the case of FeCl3, for 1 chlorine it is -1, right? For 1 chlorine it is -1, for 3 chlorine it will be -3, so in total we will be getting the oxidation number of iron as +3 here in the case of FeCl3. So what you are observing here, the oxidation number is increases from 0 to +3 for the iron, so this is the oxidation. As we already know about the oxidizing agent or reducing agent, the component that itself undergo reduction is known as the oxidizing agent, right? So here iron is undergoing oxidation itself, so it will be a reducing agent. So what is our question? We need to find out the reducing agent, right? So iron will be our reducing agent. Is that clear? Yes, increase in oxidation number means it is the oxidation, decrease in oxidation number means it is the reduction. So based on the number of based on the oxidation number, we can predict whether it is having the oxidation or reduction. Okay, I hope you understand. Now let me move to the next question. Select the oxidizing agent for the following reaction. Again, the same type of question. H2S plus I2 gives 2HI plus sulfur. Okay, oxidizing agent means it itself undergo reduction, right? So we need to find out the one which is having the reduction in the particular reaction. Reduction means oxidation number decreases. So if you are checking here, you will get this will be +1, this will be -2, this will be 0, this will be +1, -1, 0, right? Yes. So what you are observing here, 0 to -1, 0 to -1, it is the reduction. So what will be our answer? Option A, which means iron will be the oxidizing agent which is used in the particular reaction. Is that clear? As in the case of last question, chlorine is the correct one, reduction. First thing we need to check the oxidation number for each of the reactant and product. Now let me move to the next question. If you rewrite the following word equation as a balanced chemical equation, what will be the coefficient and symbol for iodine B? A reaction in words given here. Bromine plus potassium iodide gives potassium bromide plus iodine. So here we need to apply the idea of finding the chemical formula of a substance. So what will be the answer? Yes, option D will be the correct answer, which means iodine is the coefficient of the iodine will be 1I2. So how we can write down the chemical equation here? Bromine means Br2, right? Because it is a diatomic molecule. Br2 plus potassium iodide, as we already know. Potassium is the cation here, iodine is the anion here. If you crisscross the valencies, we will get the chemical formula of potassium iodide as Ki. It will be gives potassium bromide, which means KBr. Again, Potassium is having the valency of +1, Br is having the valency of -1, crisscross, it will be forming KBr. Plus iodine means it is a diatomic molecule again, I2, right? Clear? So Br2 plus Ka gives Kbr plus I2 is the reaction given here. What we have to do? We need to balance, right? So here in the case of reactant side, there will be 2 Br, so I am just putting here 2 Kbr. Now what happened? There will be 2 K in the case of product side, but in the case of reactant side, there is only 1 K, so here I multiply with 2. So what you are observing? Now the total number of atoms balanced, right? Bromine is 2 in the case of left hand side as well as right hand side. And in the case of potassium, it will be similar. Iodine is also similar. So what do you mean by here? This is a balanced chemical reaction given here, and the coefficient of iodine will be 1 only, which means I2. Option D will be our correct answer. Clear? Okay, there is different methods to do the balancing of equations. So if you are getting idea about the simple equations, you will go with that. Don't go about the oxidation number method and the other methods. So here is the next question. The solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate in solution of sodium chloride. The balanced chemical equation for the reaction is. Read the question properly. The reaction of barium chloride and sodium sulfate. Sodium sulfate solution, that is the sodium sulfate in water, reacted to give insoluble barium sulfate. Insoluble barium sulfate and sodium chloride. You need to write down the balanced chemical equation for the reaction. So what do you mean by barium chloride? It will be BaCl2, right? It will be BaCl2. Then sodium sulfate means Na2SO4 gives barium sulfate BaSO4 plus NaCl. So this is the general equation we need to balance. So if you are balanced, you will get the answer as option C here. Clear? As according to the conservation of mass, masses should be equal from the left hand side, I mean the reactant side as well as product side. So you need to check the balanced equation for here, that will be option C. Okay, I hope you understand. Now let me move to the next question. This is an assertion reason type question. In CuO plus H2 gives Cu plus H2O, the copper undergoes oxidation, and the reason Cu oxidation number decreases from +2 to 0. Option C is the correct answer here, which means assertion is correct, reason is incorrect. So what do you mean by assertion given here? CuO plus H2 gives Cu plus H2O. So it will be +2, -2, 0, 0, +1, -2, right? So what is happening here in the case of copper? Copper undergoes reduction only. So this will be the +2 to 0, which means reduction. So here there is a correction. This is the wrong statement given here. So this is false. Reason oxidation number of copper decreases from +2 to 0. So this is true. So which means assertion is correct, reason is false, which means our option D will be the correct answer. Okay, it was a typing mistake. I hope you understand. So option D will be the correct answer. Now let me move to the next question. Again assertion reason type question. Read the question properly. hydrogen gas is not evolved when zinc reacts with nitric acid, and the reason is given that nitric acid oxidizes the hydrogen gas produced to water and itself get reduced. Okay, this is the same type, same question we have discussed in the last chapter also, I mean the metals and non-metals, the special case of reaction of nitric acid with the metals. So read the question properly. Okay, if you have gone through the chapter, we can say that whenever the metals react with acid, they will produce hydrogen gases, right? Hydrogen. Okay, they will produce salt and water, but in the case of nitric acid, because of the high oxidizing power of nitric acid, instead of water, they will produce the hydrogen. They will produce the hydrogen gases, right? Which means both assertion and reason are correct, and they are the correct explanation. So, what will be the correct answer? Option A will be the correct answer. This is a special case of nitric acid. Because of the high oxidizing power of nitric acid, instead of forming hydrogen, it will be forming water plus corresponding salt. Now, this is our next question. There is an option provided here, so you can take it as an homework. Write the balanced chemical equations for the following chemical reactions. 3 reactions are given here. I will just write down the equation you need to balance. So hydrogen means H2 plus Cl2 gives HCl. You need to balance, take it as an homework. Then second case, lead plus copper chloride. Lead means Pb plus copper chloride means CuCl2. Lead chloride means PbCl2 plus copper. Third case, zinc oxide, that is equal to ZnO plus carbon gives zinc plus carbon monoxide. These are the general equation you need to balance. Okay, this is the next question. Name the oxidizing and reducing agent in the following reaction. Name the oxidizing and reducing agent in the following reaction. Just calculate the oxidation number of each of the components given in the question, given in the reaction. So plus 2, minus 2, 0, 0, plus 2, sorry, plus 1, minus 2, right? So what you are observing here, 2 to 0, right? 2 to 0, which means it is undergoing reduction. So this is an oxidizing agent. So what about the case of hydrogen? 0 to plus 1, which means it is undergoing oxidation. So it acts as a reducing agent. So in short, if you are writing the oxidizing agent as OA, that is equal to copper oxide, then reducing agent is given as hydrogen, H2. So this will be the answer for this question. Try to solve by yourself. Okay, this is the last question. On adding dilute hydrochloric acid to copper oxide powder, the solution formed is blue-green. Predict the new compound formed which imparts a blue-green color to the solution. This is a good question. You can expect this type of question. On adding dilute hydrochloric acid to copper oxide powder, we will be getting a bluish green color compound. What is the name of that particular compound? Okay, what is happening in a chemical reaction? The reactant is converting to products, right? So it is easy to find out the oxidation number starting from the reactants. Yes, CuCl2, right? So what will be our reaction given here? Dilute HCl, right? Dilute HCl plus copper oxide. As we already know in our second chapter, whenever the metal oxides reacting with acids, they will form the corresponding salt, CuCl2 here, right? Along with water, right? Along with water. So you need to balance this equation also. So the color of this particular compound is due to the presence of CuCl2, that is having the color of blue-green. So CuCl2 will be our correct answer here. Okay, is that clear? Okay, fine. That's all about from my side for today. So we have discussed practice questions for all the 3 chapters that we have completed. First chapter, chemical reactions and equations, acid, base and salts, and metals and non-metals. So in the next class, I will be trying to cover the next chapter. In the next class, I think the Tuesday. So I hope you guys enjoyed the session. If you really like the session, hit the like button, share this channel and share this particular live to your friends also. Subscribe our channel Infinity Learn 9 and 10. If you want to get the session PDF, you need to join our Telegram channel also. So thank you so much all of you. See you in the next class. Till then, bye bye all of you.